In this presentation, we're going to take a look at how we set up sheet seed definitions stored in a DGN library to populate the dialog for the users when they go to create sheets for plans or profile or cross-section sheets. This presentation will assist in developing an overall understanding of that creation process. Some objectives today in this presentation: drawing model, sheet model only, seed file creation, adding configuration variables, preparing the sheet border or the title block, creating the start seed DGN file for cross sections and plan and profiles, creating the plan only sheet seed file, creating the plan sheet seed file, creating the profile only sheet seed file, the plan and profile sheet seed file, and then lastly the cross section sheet seed file. So the first one we're going to take a look at is the drawing model file creation. The drawing model file creation is used as part of the sheet seed definition generation. When setting up sheet seed definition DGN live files, it is required to have a blank file that only contains a drawing model, hence the name drawing model file creation. This drawing model must have identical units of resolution as the project related files used for plans production.
To make our drawing model only file, let's start by making a folder called Sheets. In this folder, we're going to copy our 2D seed file into there and give it a new name. So we're going to select our new name here, seed2d imperial drawing.dgn, from our 2D seed file in our workspace. We'll go to our models and we're going to give this model a name. We're going to call this 2D imperial drawing. And with that set, we can go ahead now and take a look at the model properties. And we need to change this from a design model to a drawing model. Go ahead and set our annotation scale to a 1:1. We can review the rest of the properties here and also double check to make sure we're running the same units of resolution throughout our workspace. So in our backstage, we can go to our file, design file settings, and verify that we are using the same working units. Save those settings, and then take a look at our configuration variables that we need to point to the drawing model seed. And then lastly, we are putting those changes into our master configuration file.
Now let's take a look at setting up the sheet model only file. When setting up the sheet seed definition DGN lib files, it's required to have a blank file that may contain a single sheet model or multiple sheet models if different paper sizes are desired. This sheet model must have identical units of resolution as the project related files used for plans production.
Now let's go ahead and make our sheet model only file using our 2D seed file. And so we'll give this a name seed2d imperial sheet.dgn. Let's save and open that. Now let's go to our models dialog and let's rename this model. We're going to call this 2D imperial sheet. So we'll accept that and then open up the properties. In the properties, we want to go ahead and change the type to a sheet model. Change our annotation scale to 1:1. In our working unit section, we're going to bump up our accuracy to maximum decimal places so that if a user uses this and changes the scale in the drawing productions dialog, we will have nice even decimal numbers. Then we're going to select our sheet size of ANSI D in this example. And then we'll verify our working units are the same. Again, that's very important. So file, design file settings, make sure we have the same working units throughout the workspace. Save those settings. Then if we want to make a copy of this model, for example, for 11 by 17, we can give this a new name, this new copy. Accept that. And then all we need to do is change the sheet size, which is controlled by this file right here, sheetsizes.def. So if you need to add one, you certainly can. We're going to be using the ANSI B. That'll be our 11 by 17. And then we'll go ahead and make our default model active. And then we'll go ahead and save those changes. Then we want to set our configuration variable to the sheet model seed name and file name in our master configuration file.
The next step in the process is begin to prepare the title block that we're going to be using. The title block drawing can be a cell or a DGN file that we reference in. The title block gets placed or referenced into the sheet model of the sheet definition seed file and is used to position the drawing of the boundaries. We want to make sure the file has the same units of resolution. Let's take a look at preparing our title block border sheets. This can be either a DGN file or a cell library, depending on how you want to set this up. I'm going to just open up a DGN for our plan and profile as an example. And let's first take a look at making sure that our title block is a real size. In other words, a real piece of paper size. So if we take a measurement vertically, I have 1.833 feet. If we convert that to inches, that's a standard height. And then we have a width of 2.833 feet, which is a standard width for an ANSI D sheet. Now let's take a look at our design file units of resolution. Again, let's make sure that we're consistent throughout our entire workspace of the units of resolution. The next thing I want to take a look at is making sure that we are set to a 1:1 scale, and go ahead and save those settings. Also, I tend to turn on triad because I want the coordinates of 0, 0 to be in the bottom left corner, and you'll see that that is correct. Now, these blue borders on construction class represent our port areas for our plans. In other words, in this example, we have a dual profile, but we may have a plan and profile or a plan only, and you'll see that those are drawn to a construction class as a microstation element. And if we measure those distances, those are the expected station distances that we would get in this example for a profile view for our width and our height. And you'll see there for our second port, for if we have a dual profile sheet, making sure that those heights are consistent. So we have some different models in here, different examples, plan and profile combination, plan only, profile only, a dual plan sheet, and a dual profile sheet with the construction class boundaries represented in each view. To begin to prepare for creating the cross-section sheet seed definitions, we want to first make a cross-section starter seed file. This DGN file has unique requirements. It must contain a horizontal alignment. The alignment can be a simple straight line civil geometry element. It must contain an active vertical alignment. It must contain a corridor where the template can be made of something simple like a single null point. At the completion of this drawing, make sure to have both the 2D plan model and a 3D model opened and save the settings of the DGN file. Make sure it has the same units of resolution as everything else that you are setting up. Let's make our cross-section starter seed file that has our alignment and our corridor in it. And so we'll start with our 2D seed file, give it a name cross-section start.dgn, save that. Verify that your scale is 1:1. If it's not, go ahead and change it and save your settings. Verify your units of resolution. Again, we're going to do this every time. Make sure that it's the same throughout your workspace, anything to do with sheets. Let's jump over to our corridors and to our create template dialog. We'll make a new template. I'm just going to call this null point, and literally a singular point is all we need. Don't really even care about feature definitions. Just set that to the center. Go ahead and save it. Now in our Geometry tab, we're going to place our first alignment. We want to make sure we're set to no feature definition. And press the F6 key, it'll open up your key in. I'm going to start at 0, 0, so xy equals 0, 0, enter. That'll start our drawing command. Then I'm going to put in a distance of 100 and hit enter, tab over with my arrow key and put a direction of 0 and enter that. Then I'm going to select profile by constant elevation. And I'm going to set, again, no feature definition and elevation of 0 for my profile. Cancel out of that command. We can open up the profile view, verify that our profile that we generated is active. So if I select that, just verify that the second icon shows it to be active, and it does. We can close our profile view now. We want to create a corridor. Again, make sure your corridor feature definition is set to no feature definition. Select your baseline. Reset to use active profile. Don't care about the feature name here, just so accept. On the template, we're going to choose our null point template that we just created. And after you create this corridor, you can go back and delete that null point template. So we'll accept that template, Alt to lock start, Alt to lock end. And we can just put in a value of 50 feet, which would be the midpoint. It doesn't really matter. Go ahead and accept the rest of the defaults to create our corridor. Right-click View Control, Plan 3D to open up our 3D model. Want to change this to wireframe. And then I typically like to rotate this a little bit just to let the user see that this is truly a 3D file. Save those settings. Now we want to go to Project Explorer, make sure we don't have any annotation definitions or groups or feature symbologies or feature definitions. So go through each of the categories, make sure there's no entries in here. If there are, we're going to delete them. For example, there are feature symbologies in here for surface and linear. So delete our linear. And in our feature definitions category, we're going to get rid of those as well. We also need to check our element templates. So we'll delete those. We can close that and make sure also we don't have any extra levels in here. We should just have the default level. And so we're good. Go ahead and compress the file. And I typically like to save settings at this point. Now we want to go ahead and prepare the plan and/or profile starter seed DGN file. Again, this file is going to have unique requirements. It must contain a horizontal alignment. The alignment can be a simple straight line for civil geometry. Has to contain an active vertical alignment. And then at the completion of this drawing, make sure to have both the 2D plan model and the profile model open and save the settings of the DGN file. Again, make sure it has the same units of resolution. Let's make our plan and/or profile starter seed file. And so we'll give it a plan or profile start seed.dgn name from our 2D seed file listing. Again, set our active drawing scale to 1:1. Save those settings. Verify our units of resolution or our design file working units are the same, again, throughout the project. Now we want to go to our Geometry tab, place linear geometry with no feature definition. And again, I'm going to use the F6 function key to open up my key-in. I'm going to use the XY equals 0, 0. That's not required. It's just a convenience of location. I'm going to give it a distance here of 10,000 for imperial. That's irrelevant, the size, but I typically like to make it long enough to cover my widest sheets. Give it a direction of 0 and accept it. Then we need to set a profile elevation again by constant elevation. Again, no feature definition here. So we'll select our horizontal geometry. And I'm going to set that at an elevation of 0. And then we're going to right-click, View Control, and open up our plan and profile combination by selecting our horizontal geometry. And then selecting our profile window. And you'll want to make sure that that is an active profile as well. Then we want to navigate down, make sure again no annotation definitions, annotation groups, feature symbologies, or feature definitions got copied into this file. So if they are, go ahead and delete them. Same thing with element templates. So we'll go to manage those, verify those are empty. And then lastly, our levels. Sort by used levels, and again, just the default here. Then we can go ahead and compress our design file, and lastly, save our settings. We're going to start creating our Sheet C definition files now. We're going to start with a plan-only Sheet C definition DGN library. This file is considered a preference file. Basically, you're storing your preferences in your DGN library. This preference file will support creating a plan-only DGN file. It's going to be used in the DGN library format, where the starting file to use is a start C DGN file for plan and or profile that we just created. A part of this process will be to generate a drawing model and sheet model within the file, storing the necessary properties. And the sheet border will get attached to the sheet model as the last part of this exercise, or placed as a cell if preferred. To create our plan-only Sheet C definition, I first want to find out the dimensions of our port for our plan view. And so in our border file that we worked on prior, if we go to that model of our plan-only sheet and take our vertical and horizontal measurements, we can then compute those actual real distances based on our scale and the fact that this is imperial. So we have take our dimension times 50 for a 50 scale times 12 to take it into our units proper for this. And so you'll see our dimensions of 1400 by 800, and that's real feet dimension. We will take our plan and our profile start seed. We're going to make a copy of that. We're going to rename it. And this is going to be our plan sheet seed 50 scale.dgnlib. Make sure that you completely close out of the product before you open this dgnlib. That is a requirement to generate sheet seed definition DGN files. And so you want to exit the product and then open that dgnlib that we just generated. With the file open, now let's go ahead and go to our named boundary place tool. Make sure we're in the plan mode for this example. We do not pick a drawing seed, we're making one. We do pick our scale. We don't care about the name, the description, or the group or the name, or that description. Those will be filled in by the user and are not stored in the seed file. Put in our length we computed, and then we put in half of our height, which is going to be 400 master units left and right. If you want an overlap, you can specify that. The boundary chords designate the segments along the boundary, and we'll go ahead and turn on our create drawing. Select our start location field, pick our baseline, lock it into the beginning, accept that, and then somewhere in the first boundary, go ahead and do a second and a third accept to take us into our next dialog. Give this a name of the sheet seed that you want the users to see in the pull down. If you don't have a discipline for civil, go ahead and manually type it. The purpose in this case will be plan view. Set your scale again for your drawing model. It should match your design model. Also on your detail scale, that is 1 to 50 as well. And your paper to drawing ratio is 1 to 1. If you have a plan annotation group, for example, like a plan grid, you could select that here, and that would be remembered. So let's select OK. We want to go ahead and move the drawing boundary handle over to the left. Then we want to go to our reference dialog. I want to attach our plan border that we prepared. Make sure you pick the right model. Select OK, and it will fall into the right place. Then we want to go ahead and select our two entries, toggle off the scale line styles by reference, and then we want to move the first reference from its upper left corner to the proper location in our drawing boundary that we had set up prior. Now we need to delete the drawing boundary handle for the reference file of the border. Do not detach. We're done with our reference dialog. Select the other one and move the corners to the proper locations. Then we want to do a fit view. Let's turn off that construction class now, which is our blue boundary. in this example. We can go ahead then and save those settings. Let's drop over to our drawing model. We'll do a fit view there, save those settings. And in our multi-model view, which is our plane and profile combination, I want to go ahead and change the symbology of our drawing boundary to draft name boundary and by levels, classes, construction, transparency 50%. Open up Explorer, verify again that we don't have any annotation definitions, groups, feature symbologies, or feature definitions. If there are, you need to delete those in this file at this time. Same thing, make sure we don't have any element templates that were copied in. Make sure those are gone. Then we just switch back to our sheet model. At this point, I would typically do a compress file and then save settings.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.